Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and this is my third biography of mathematicians that I'm featuring in my new feature on the Math Lovers book. I think I mentioned in the last two that I have biographies of 80 famous mathematicians throughout history, and I'm going through them all in chronological order, one per week. And a couple weeks ago, I did a brief biography on Pythagoras, who's often considered the father of mathematics, also known for the Pythagorean theorem. Then last week I featured Hippasus, who was one of his member of his cult, who proved that the square root of 2 was irrational and got drowned at sea for it, supposedly. Today I'm going to talk about Plato. I'm sure you guys have all heard of him. He was a very famous, not just mathematician, but philosopher. And here's a brief bio from my book about him. And he did a lot of important contributions to philosophy. His big thing was he believed in these ideal forms. He thought that he was known as a dualist, kind of like Rene Descartes about 2,000 years later. He thought that there was the real world, the world we live in, the material world, if you like. And then he thought there was what he called a world of ideal forms, which I think now we would maybe call spiritual realm, or some people even think it might be heaven. He was thinking about, even though the concept of heaven wasn't quite in place yet. But basically, his idea of the world of ideal forms, he thought that everything in the world had an ideal form in this ideal world, and kind of a weird idea. I mean, he thought there was like perfect tables and perfect chairs and perfect houses and I guess perfect people, maybe, I don't know, but perfect everything basically. But I'm not a Platonist in that sense. I don't believe in this world of perfect forms. But what I do believe in, which is a big part of his world of ideal forms, was mathematics. He said that for every mathematical construction that we can make here on Earth, like with a compass and straight edge, we can draw a circle, or the Earth we now know is approximately a sphere, but not exactly. I mean, it's got mountains, and also it's more oblate spheroid shaped. It's a little flatter at the poles, but Plato thought that there were ideal mathematical forms, and I do agree with him about this. I mean, we can mathematically define an exact sphere. It's just a set of all points in three dimensions that are equidistant from a given point. And you can find that precisely mathematically. And we've even made spheres that I think are correct within just one or two atoms variation. Pretty amazing. I watched a YouTube video on that once. So I do believe in ideal mathematical forms. I think that was his greatest contribution to mathematics. And not only that, he made some specific contributions, in particular the five Platonic solids. And I'll just show you what those are. I think you probably guys are probably familiar with these. There's five. These are the five sort of regular 3D figures in the same sense as regular polygons. There's infinitely many regular polygons. Those are just polygons with given number of sides that are completely, like n sides would be a regular n-gon, I guess you would say. I mean, regular equilateral triangle is a regular triangle, a square is a regular quadrilateral, so on. But there's infinitely many of those in two dimensions. In three dimensions, there's only five. There's only five regular 3D solids. When I say regular, I mean that all the faces are congruent and they have as much symmetry as possible. And there's five of them. There's the tetrahedron, which has four faces. We call them faces. I guess the next one they show here is the octahedron. That has eight faces. I don't know why they showed that before the cube. The cube, also known as the hexahedron, that's the one in the middle, the one in green, that has six faces. The next one's the icosahedron. Again, they skipped in terms of faces. The icosahedron has the most faces of any Platonic solid, 20, but they're equilateral triangular faces. And then the last one's a dodecahedron, which has 12 pentagonal faces. So there's five Platonic solids. And Plato, I guess he was kind of a mystic too. And he thought, I guess there was another guy before him named Democritus. There was another Greek philosopher that came up with the idea of atoms. He said that every substance was composed of atoms, and he was basically right, except he just theorized. There was no scientific evidence for anything because there was no modern science. But he had the right idea. There are atoms; they just weren't what he thought they were. And then later, I think, I don't know if it was Democritus himself, but I know that at least Plato, who came shortly after Democritus, believed that there were five, types of matter, five elements, I would guess you would call them, classical Greek elements. At first, there were only four. Air, I guess we'll go in order here. Fire would be the tetrahedron, shown in red. I guess they attribute that to fire because it has the sharpest vertices. It's the most harmful if you touch it. The next one's air, the octahedron. I guess they associate with air, shown in yellow. The cube was associated with Earth, which kind of makes sense because it's easy to build things as cubes, and maybe they thought the Earth was made up of small cubes. They stack together nicely, and they're very compact. And then the water was the icosahedron. I guess that would be the slipperiest one, since it's the smoothest one, the closest to a sphere, I guess. And then the last one, which came later, I don't think they even accepted this at first, was the ether. The idea of the ether, that's the stuff that makes up the heavens. And that was associated with the dodecahedron. And I think for a while it was even forbidden knowledge. The I mentioned that there's one theory that Hippasus, the one I mentioned last week, was drowned at sea not because he proved the square root of 2 is irrational, but another thing he did was he discovered the icosahedron. I think this one was discovered after the other four. Plato knew about all five of these, but I think most of the Greeks only knew about the first four. The dodecahedron came later, and since there were only four classical Greek elements, we needed a fifth one, and so that was just given the name the ether. It was a fictitious substance that made up the heavens, and I think I just want to say one more thing about this before I get off. I mean, obviously, there's more than four elements. Now we know, I think, 118 chemical elements, Uh, but, and none of these actually turn out to be real elements. I guess the closest one was water, which is H2O, consists of two different elements, a molecule with three atoms, two of one element, hydrogen, one of another element, oxygen. And fire isn't even a form of matter. Air is, but it's a mixture of different gases. Earth again is a mixture of different solid substances. So none of these are elements. But the ether, it's kind of funny. The ether didn't die right away, even though it was a fictitious substance. It came back in the 19th century, and even I think part of the early 20th century. And the reason that the ether came back, this is kind of an interesting thing, and I'm jumping the gun way ahead on the history of math and science, but there was a problem with Maxwell's equation. There was a problem with classical mathematics in the late 19th century. The problem was that Maxwell's equations were not compatible with Newton's law which was the kind of classical physics at the time, because the problem was that light always predicted by Maxwell's equation to move at the same speed no matter how we were moving in it. And so they hypothesized that there was this fictitious substance called the ether that made up the heavens, and the ether had to be at rest. The speed of light had the ether was the medium for the propagation of light waves. Kind of a natural phenomenon, assumption, because every other wave anybody'd ever studied before needed a medium. I mean, water waves obviously need the water. Sound waves go through air or through whatever substance is propagating the sound wave. Waves on a string or on a rope. The rope is the medium, or a guitar string, or So it seemed like every medium needed every wave needed a medium, but light didn't seem to have a medium, and that I guess physicists at the time couldn't accept that there could be a wave without a medium. It actually turns out it's true, but that's why they invented the ether to they thought that was the medium for light propagation, but then it turned out that they couldn't measure any motion through the ether. That was the failure of the Michelson-Morley experiment. in 1881, I believe, and that ultimately led to the theory of relativity. Einstein was able to come up with a theory of relativity as a way to explain how light could always appear to move at the same speed no matter how you're moving. So it doesn't need a medium, and also space and time transform in ways that are very counterintuitive. So I just thought I'd mention that. So we kind of got on the wrong track with ether a few times, but anyway, that was Plato. That was Plato's contribution to math. Very very significant contribution that lasted. Is still on. And anyway, that completes my biography of Plato. Thank you for watching. Long live math, and I'll see you guys next time. Bye.